Hi everyone, welcome to the video about analyzing functions from their graphs. So to begin with, take a look at your note sheet. I gave you this graph, and the first thing that we're going to do to help us to analyze a function is to make a slope number line. A lot of the analysis that we do with our graphs has to do with y values increasing or decreasing, where the slope changes, and that's what the slope number line is going to help us do, is kind of organize those thoughts. So let's draw a number line to start with, and we're going to label the top of this number line slope and the bottom of it x. So we're going to be making some indications here on the top about the slope, and down here about the x values where the slope is important. So now let's take a look at our graph. When we read graphs, we're going to read them just the way we read words, and that's from left to right. So here's the left side of the graph. If I were to trace this graph from left to right, like this, notice that the graph is actually moving downwards, even though there's an arrow pointing up here. So notice that that downward movement stops when we hit an x value of -3. I'm going to mark that on my number line over here. That downward movement really means that we have negative slope from -infinity up until -3. If I continue reading my graph from -3, from left to right, now I have a part of the graph with a positive slope. Let's mark off where that stops being positive, right here at 1, and we'll mark it on our slope number line as a positive slope. It's increasing the y values as we move from left to right. And then to finish it up, we have this section here, which is back to decreasing. So from 1 to infinity, there's a negative slope. So this gives us a lot of information to work with. The first thing that we're going to do is to write down the increasing intervals. So increasing isn't about where the arrows are pointing, it's about the slopes. So you can think of that two different ways. As the x values are increasing, the y values are increasing. And the reason we said as the x values are increasing, that means that we're moving from left to right. If I was going from right to left, I could say, oh yeah, from here to here, look, they're increasing, But that's not how we read things. It always goes from left to right. And the other way of saying that, something's increasing, is that we say the graph has a positive slope. So here we had a positive slope for one of these intervals, and that was from -3 to 1. Now, there are different textbooks that will tell you that you can include those two values in your increasing interval, and there are textbooks that will tell you that you shouldn't include those values. I like to not include those. That's just the way that I was taught. I think it makes more sense that way. When it comes time to grade your answer for increasing or decreasing, in this situation, I actually would give you credit if you had parentheses or brackets here. There are going to be graphs where it matters, and I think we're going to get to one of those on our last example. I think it's just safer to go with parentheses. It's going to be the default. All right, so let's move on to the next section, which would be decreasing. And that is where the y values are decreasing as the x values increase, or in other words, where the graph has a negative slope. We had two intervals here that had negative slope. We're going to write down both of those intervals, so from -infinity to -3, and 1 to infinity. Okay, next up, let's talk about the extrema. Extrema is a term that encompasses many things that you need to think about, but really The key word there is extreme. Are there any extreme points on this graph? So to begin with, let's think about the largest y value in our range, or in other words, the highest point on the graph. That's going to be called the absolute maximum. So if I look at my graph here, right, I notice that this is going to keep, right, it's going to keep giving me points that have higher and higher y values. So there is no largest y value in the range. This graph would not have an absolute maximum. And then if we go the other way, right, we're going to consider the absolute minimum, or the smallest y value in the range, right? And we have this arrow here telling us that there are more points that go farther and farther into the negatives. So there is no absolute minimum. There's no smallest y value on this graph. Okay, so those are two types of extrema. Absolute, right, meaning the largest or the smallest, right, depending on if we're talking about maximum or minimum. But there's another type of extrema, and that's called a local maximum. In some textbooks, or some teachers will also refer to a local maximum as a relative maximum. So it's important that we know both of those phrases. And this is where the slope changes from positive to negative. So let's take a look on the graph here. If the slope was positive, that would be this green piece, right? And it changes from positive to negative, that would happen at this point right here. And you could see that it's special, right? In fact, if we were to just look at this section of the graph, like give it a little neighborhood here, a very small neighborhood, it would look like it is the highest point on the graph. Even though we know that there are points over here that are higher, in this little section, it sure does look like a maximum, right? And that's why it is special, okay? In its little local neighborhood, it could be considered a maximum. So that's where the name comes from. It's a local maximum, but really it's because the slope is changing. And see right here that on our slope number line, right, we didn't even need to see this graph anymore. We could see that from changing to a positive to negative slope, that there must be a point here that's special. Now, the other thing is that this graph has to be continuous, meaning that these pieces connect, right? So this is a positive slope, negative slope. I didn't have to pick up my pencil, right? Those pieces connect there. Okay, so I'm going to write down that our local maximum on this graph is at 1, 14. And we have one other extrema we need to talk about, and that's the local minimum, also known as the relative minimum. And that's where the slope is going to change from negative to positive. And we had one place where that happens, right here at -3. You can see the point right here. So we'll label that. That happened at -3, and I said this is about here, which was -13, right? And it looks like in this little neighborhood that it would be the lowest point, even though we know there are points that are absolutely lower, right? Which is why this is not the absolute minimum, it's just a local minimum. And we can talk more about this in person, but it really is important to start to know this vocabulary and how to identify these points. Okay, next up, we're going to talk about the zeros. That's just another word for x-intercept. So right now you should know that an x-intercept is where the function crosses the x-axis, right? So here's the x-axis. We have this graph that crosses it at 1, 2, 3 different places. Okay, so I can refer to these as the x-intercepts, or I could refer to them as the zeros, okay? And when we write them down as an ordered pair. All right, so we have -4, 0, -1, 0, and 2, 0. And those are going to be important, especially when we're writing equations from a graph. So it's an important part of our analysis. I could also ask you for the y-intercept. It doesn't have a special name, so I didn't label it here, but we'll come back to that later. Okay, so end behavior. This should seem new. It's kind of a weird phrase, but it's a really simple idea. And the end behavior is something that describes what y value a function approaches as x approaches infinity and as x approaches negative infinity. In other words, what is this arrow doing and what is this arrow doing? So we're literally talking about how the ends of the graph are behaving. The hardest part about this is the notation. So we're going to do two different types of notation. The first one is using limits. Okay, and when we use limits, we're going to need to have a name for the graph. So I'm giving it a name. Let's label this graph f of x. Okay, so here we go with our first limit. A limit is just a mathematical way of referring to something that approaches something else. Okay, so what this is saying is the graph of f of x, right? It's referring to that. It's saying as x approaches negative infinity. That means I'm looking at the left arrow. What I write down here after the equal sign is what the y values are approaching. Well, they keep going beyond here, right? Up into these really positive values. I don't see an end in sight, so I'm going to say that they are approaching positive infinity. Okay, I'm going to say this one more time, how you say this. The limit as x approaches negative infinity of f of x is infinity. So this was the left arrow, but this graph has two different ends to it, so I have to do both. So now I'm going to talk about the right-hand arrow. So now this is the limit as x approaches infinity, right? Here's the x-axis, here's infinity. That's why we're talking about the right-hand arrow, where the x's are positive. This arrow is showing us points that keep going down here into the negatives with no end in sight, which is why the answer to this is going to be negative infinity, right? So it really is saying, what is the arrow pointing to? That's the big idea, and here's just a more complicated way of writing that, which hopefully in the future isn't going to be so complicated. We have a reason for writing it this way. Just as a backup, we're not going to require you to always use this limit notation. If you feel more comfortable using this sentence right now, that's fine. I'm just going to read this the same way that I read this up here, except I'm not going to use the word limit. So I say, as x approaches infinity, well, actually, that's going to be this bottom one first. Then f of x approaches negative infinity. And now the equivalent to the top limit is this sentence down here. As x approaches negative infinity, f of x approaches positive infinity, right? So we would require either this answer in limit notation or this answer in English, right? That's basically what that is, with the intention that eventually you're going to use this limit notation, okay? This is something that you will definitely be using in pre-calculus and calculus. Okay, let's try another graph. So on the back, you have the picture here to work with, and we are going to analyze this function. So if the directions ever say to analyze the function, what they're saying is figure out what the domain is, the range, increasing intervals, decreasing intervals, the zeros, the y-intercept, all of the extrema, and the end behavior, right? That is something that you have to know. We do not have to ask you these individual things, right? This is all part of the analysis. So let's go right to it then. This video doesn't talk about domain and range. That was in the previous video. So I'm just going to go through that pretty quickly. The domain of this graph, let's see, no discontinuities there. So we're going to say that's negative infinity to infinity. Range, we're going to go with low y value of -9. No limit on the high y value, so we'll say -9 to infinity. And now we're in to increasing and decreasing. I highly suggest that you draw a slope number line when you do this, or at least for when you're getting started. Don't feel like you have to do a slope number line. It really is just a tool to organize your thoughts. So let's do one for practice. So on the slope number line, we're going to put down the places where the slope changes. All right, so if you trace this from left, change to right, another change, right, another change here. Looks like we had 3 places where the slope changed, so we're going to get those on our slope number line. First section was a negative slope, second one positive, the third one was negative, and the last one was positive. Okay, so wherever we have a positive slope, those are increasing intervals. So let's get -6 to 0 and 5 to infinity as our answer for increasing. And then our negative slope, those are going to be our decreasing intervals. So -infinity to -6 and 0 to 5. Okay, next up the zeros, the x-intercepts. So I see 4 of them. The first one is here at -8, then the second's at -3, 4, and 6. Y-intercept, that's just going to be where the graph crosses the y-axis. You should only have one of those, right? So this one is at 0, 7. We also write that as a point. Okay, so here come the 2 big ones. Extrema. Think about the absolutes first. Is there a lowest point on this graph? Yes, it's right here. That's going to be our absolute minimum. It happens to also be a local minimum. So notice I labeled it both. It's absolute because it is the lowest point on the graph. It's local because the slope changed from negative to positive. So I wrote that point down. We had 2 other places, right, where the slope changed. So that second one is a local maximum at 0, 7. Slope changed from positive to negative. And then the third one here, local minimum, slope changed from negative to positive at 5, -1. There is no highest point, right? We know that these points are going to continue getting to be more positive, so we don't need to write down an absolute maximum. Okay, lastly for end behavior. So let's talk about the left-hand arrow. So I'm going to use my limit notation that says as x is approaching -infinity, left-hand arrow. What is this function doing? Oh, all the points are up here in the positives. So that limit's going to equal positive infinity. And then lastly, we have the right-hand arrow. In other words, as x is approaching positive infinity, what are the y values that this is getting closer to? Oh, also positive infinity, right? So that says both arrows are pointing up. This is what we will be doing with the functions in this class. And we can do more with this stuff later on, but we need to be really good at this. These are like the real basics of Algebra 2. Okay, let's do one more example. So we had a piecewise function to look at. It's a little weirder. Let's talk about domain. In the previous video, we did the domain of a piecewise function. Here, it looks like we have 2 big jumps, but it turns out that there are no gaps in the domain, right? Because this one is including -1, and this one's including 2, so all x values are included, so our domain is -infinity to infinity. Our range, we're going to look for the lowest y value, so that's -6. Highest y value, we don't have one, that's going to keep going up to positive infinity, so we got our range. And now it's time for increasing and decreasing. So if we read this graph from left to right, first piece is decreasing. Second piece has a portion that's decreasing and a portion that is increasing. And then the third piece is increasing. So increasing, we're going to start here at 0. We're going to skip over 2 because at 2, right? It's not connected, so we can't include that as part of our increasing interval, and then we'll continue that to an x value of positive infinity. And this is why I say to use parentheses. It's just safer. We don't want to include 2 as being increasing, right? Because we go from 2, 4 all the way up here. Although that is an increase, it's a very weird situation. That's all I'm going to say about that. And then for decreasing, we had this portion, right? Ooh, but see, now this piece is higher up, right? But from here to here is still decreasing, so we don't want to include that -1. We'll leave that out as well, right? There's a really good example of why you don't want to include that point. Okay, finishing this up, we got an x-intercept right here at -4, another one right here at 0. We write those as ordered pairs. 0, 0 is also the y-intercept. And that brings us to extrema. So we definitely have an absolute minimum, right? We have this point right here. It is the lowest point on the graph. And we have a change in slope right here. So that's going to be our local minimum at 0, 0. These endpoints here, there's no change in the slope from here to here, here to here. So we're not going to worry about those as being extrema. They're kind of a weird situation. And we don't have a highest point. So we've covered all of our extrema. End behavior, we're looking at the left and right hand arrows. This is very similar to the last one, right? It doesn't really matter what happens in the middle of the graph. It's just asking what's happening at the ends of the graph. So we are going to have the same answers here. The limit as x goes to -infinity of f of x. The left-hand arrow, that's going to infinity. And then the limit as x approaches infinity of f of x, that's the right-hand arrow, that's also going to infinity. And don't forget, if you don't want to use the limit notation, then use a sentence. Just make sure it's correct. And we'll be doing a lot more practice with this. We'll be doing this all year long, but it really is important that we make sure we understand these early on so that we can focus on more difficult things later. All right, good luck and have fun analyzing functions.